Hello, class. Today, we're going to talk about rules of inference. Now, you just finished filling out your notes for rules of inference with modus ponens, which you may have recognized from your time in geometry as the law of detachment. Modus tollens, which you may have recognized from your time in geometry as the law of contrapositive. Elimination. Transitivity, which you may have recognized from your time in geometry as the law of syllogism. And then generalization, specialization, conjunction, and contradiction. We're now going to look at how you can apply that to argumentation and justifying yourself. So we always need to put a justification. Now, as y'all know, I'm homesick with the flu, my constant friend, hooray. And my printer decided not to print some things and to print some things oddly. So bear with me a little bit here. All right. We're given the statement, if P is true, then Q is true. That's a premise. We're also told that P is true. That's another premise. And from that, we know that Q is true. Now, how do we know that? Well, we know that because of modus ponens and the truth table that proves its accuracy. And so we justify ourselves by saying modus ponens. All right. Next, if P is true, then Q is true. That's a premise. If Q is true, then R is true. That's a premise. Therefore, if P is true, then R is true. Well, that is the law of transitivity that we saw with the proof there in our notes. So we just write transitivity because that is our justification for making the claim that if P is true, then R is true, as long as these two premises are also true. All right, so now let's look at kind of a blend. If P is true, then Q is true. That's a premise. That's like a given. If Q is true, then R is true. Another premise. So if P is true, then R is true. Well, we just saw that we know that by transitivity. And then another premise. P is true. Well, since I know this by transitivity, as long as P is true, R must be true by, you guessed it, modus ponens. So, that's how we use logic to justify the statements we make. Now, let's take a look at what that looks like with actual statements. You're going to see, this will be at the top of your next page. Use logic to find a conclusion to the following statements. Alrighty, let's see what our first one is. Premise 1. If I eat an ice cream, then I get a brain freeze. All right, so I'm going to say P arrow Q. I eat an ice cream being P. I get brain freeze being Q. So I'm going to say P arrow Q. If P is true, then Q is true. And that is a premise that was given to me. All right. Michael said that I didn't eat ice cream, but that was a lie. All right. Well, what that tells me is that not P, which would be I didn't eat ice cream, is false. All right. Not P is false, and that's my other premise. Well, that happens to follow the law of contradiction. If not P is false, then P is true. Therefore, if not P is false, I know that P is true by contradiction. Well, then if P is true, therefore Q is true by modus ponens. So therefore, I got brain freeze. Okay? Let's do a couple more. Premise 1. If I run a marathon, I'm going to make that P. Then I get a free blanket. That's Q. So if P, then Q. All right? And that is a premise. I ran a marathon and I ran a 10K. Okay, so that's P and R. That's a premise. Okay, so here, R doesn't help me much. I need to say that P is true. But remember that specialization lets me say that if P and Q are both true, then P is true. So if P and R are both true, I can just say that P is true by specialization. Oh, well, now that P is true, therefore Q is true. So therefore, I got a free blanket. Excellent. All right. Now this last one, for you, it's all on your third page. Oh no, I'm sorry, second to last one. For you, it's all on the same page, but for me, it got split up a little. That's okay. Let's take a look. Premise 1. If you watch the video, then this worksheet makes sense. Well, watching the video is P, and the worksheet making sense is Q. So if P is true, then Q is true. That's a premise. All right. Oh no. The worksheet doesn't make sense. All right, well, that means not Q is my other premise. Oh, wait, I've seen that. That is here. If P is true, then Q is true. So if Q is not true, P cannot be true by modus tollens. So therefore, not P by modus tollens. And the conclusion, therefore, I did not watch the video. All right, last but not least, I have the flu or I'm at work. PQ. All right. Premise. I'm not at work, clearly, as you are watching this video. That is the other premise. All right, where can I find something like that up here? Let's look. Oh, right there. Got it. If P is true or Q is true and Q is not true, P must be true. All right. That's the elimination property. So therefore, P must be true by elimination. So therefore, I have the flu.